and tell me who has joined the session. So bachcho, today's session is going to be a continuous session that we have done in yesterday's class. So kal ki class mein basically we have started the transient analysis. We have seen the few questions over the first order circuit. Basically we have seen question over the RC circuit, right? We have seen the questions over the RC circuit, in which we have seen the RC source free circuit and also the forced circuit, right? So जल्दी से बताओ किस किसने सेशन ज्वाइन कर लिया, and then we will start our session. And बच्चों ट्रस्ट मी, एक बार ये आपकी सीरीज कंप्लीट हो गई ट्रांजिएंट एनालिसिस की, 2-3-4 दिन की सीरीज है. यू आर गोइंग टू बी अ वेरी गुड इन सॉल्विंग दीज क्वेश्चंस, ट्रस्ट मी. और कोई भी डाउट होता है यू कैन आस्क मी, यू कैन ज्वाइन माई टेलीग्राम चैनल. अपने डाउट आप वहां पर पोस्ट कर सकते हो. अगर डाउट आपके क्लास के रिलेटेड होंगे तो वी विल सॉल्व द डाउट ऑन अ लाइव सेशन, अदरवाइज मैं वहीं पर आपको आंसर दे दूंगा. गुड इवनिंग अशोक. ओके, first of all, like the session and बच्चों share the session among your friends so that more and more students can join. And before starting a session, बेटा आप लोगों को एक एडवाइस देना चाह रहा हूँ मैं. आई होप कि आप लोगों ने टेस्ट सीरीज स्टार्ट कर दी होगी, बिकॉज एग्जाम में अब जस्ट 4 मंथ्स बचे हुए हैं. जितना सिलेबस हो गया उसके हिसाब से अपनी टेस्ट सीरीज स्टार्ट करो. कंप्लीट दो सब्जेक्ट्स यू हैव ऑलरेडी डन. कंप्लीट द टेस्ट सीरीज ऑफ दो सब्जेक्ट्स. ओके, बिकॉज प्रैक्टिस बहुत जरूरी है. अगर आप प्रैक्टिस नहीं करोगे ना तो फिर दिक्कत हो जाएगी. ओके, अंडरस्टूड. चलो, तो लेट मी इंट्रोड्यूस माई सेल्फ. वेट अ सेक. हाँ, this always getting wrong. So my name is Shan Mudgal. I have a 7+ year of teaching experience. I'm Tech Gold Medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. And right now we are doing network theory. So before starting a session, I told you about the importance of test series. तो उसके लिए हम from the BYJU'S exam prep are bringing a all India open mock test. This is free for all of you. This mock test is going to start from 14th October. You can see the date, time and the result date, and also the test syllabus. And this will be the pattern of the questions going on. So you can give this all India open mock test and revise your concepts very well. Also, bachcho, you can register for it. It is going to be live from 14th October to 20th October. So don't forget to register for it. Okay. चाहो तो इसका screenshot ले लो. This is going to be your particular duration, syllabus and all. Okay, but you have to revise the concept very well. Now, also, scholarship test is going to happen on our platform at 15th October. If you are going to plan for the next year GATE examination, we are going to provide 90% scholarship for all of your programs for GATE and ESE. So don't forget to register for this examination. Also, bachcho, on today, Abhinav sir is going to bring a session on the particular topic of is it possible to cover all syllabus before 2024 examination. This particular session will help you to revise the concept in less amount of time and help you to plan how you can go ahead for the next 4 months. Okay. तो बताओ किस किसने सेशन ज्वाइन कर लिया. I can see अशोक लाइव है. Anybody else? Anyone else? Anyone else? Okay. So wait a sec. Wait a sec. हाँ. So I guess there is one problem here. Okay, no problem. Let me add few pages. Let me add few pages here. So in the last class we have done the RC circuit on the first order. We have done the source circuit and source free circuit. Today we are going to start with the RL circuit. Now again, if I'm saying that we are doing a RL circuit, it means I'm going to do the first order analysis again. So for a RL circuit, again there will be two type of circuit. One will be source free and another one will be forced. Now, just I told you in a last class, if you have a source free circuit, then always understand the energy storage element is going to be store energy initially. Okay, otherwise the circuit will never work, because for circuit to be work there should be some energy delivering element present here. So that work will be done by either inductor or capacitor. In a forced circuit, there may or may not be energy stored in particular energy storage element. So first we are going to see the particularly source free circuit. Okay, let's understand. I have a switch to provide the sudden disturbance. This is a resistor. This is going to be a inductor. L, R, and suppose that switch is going to close at t equal to 0. I'm assuming that the current is going to flow in this direction, which is I, and we need to find out the current IT. And it is given that initially inductor current is I naught. Initially inductor current is I naught. It means inductor has stored the energy in a particular magnetic form. So initially it has stored the current of I naught. So we need to find out the current IT for t greater than 0 when the switch has been closed. Okay, so everybody try to solve the question and give the answer. सब लोगों को try करो. Simple कैसे होगा देखो. I'm going to apply the shortcut method that I told you in the last class. You can apply it directly, or if you want, you can use the partial differential method also. But always remember, Gopi saying, sir, voltage is placed in series with switch. Not, sir. But that will be a forced circuit. Right now, we are doing the source-free circuit. So, in a source-free circuit, there will not be a source connected here. The inductor is charged initially, so it will be act like an energy delivering element. So, after switch will be closed, inductor will deliver the energy. After that, we will do the forced circuit. In that, we are going to use the voltage source. Okay, समझे इस बात को? Yeah, you are saying anything else? Okay, so here, what is the shortcut formula? Simple है. Shortcut formula IT is equal to I infinity minus I0 plus e raised to power minus t by tau. Now, if you see here very carefully, we already know what is I0 plus. I0 plus is the initial current. I0 plus is the initial current, which is actually I0. Now, what is the I infinity? Now, understand this concept, bacha. Understand this concept. I infinity is the current inside the inductor at steady state. Now, this particular circuit, inductor is in discharging mode because it is delivering the energy to resistor. So, can I say at t tends to infinity at steady state, all energy which is inside the inductor will get discharged? If all the energy inside the inductor will get discharged, so inductor will not have any energy at steady state. So, simply I can say what is I infinity? I infinity will be 0. I can say directly I infinity will be 0 here, right? Now finally time constant, it is a RL circuit, so time constant will be L by R. Time constant will be L by R, right? So finally I can put all the values here. IT is equal to I naught minus, sorry, my fault. I infinity is 0 now. So IT is equal to 0 minus I naught e raised to power minus t by tau. So this comes out to be I naught e raised to power minus t by tau, or tau is nothing but equal to L by R. Tau is nothing but equal to L by R. Understood this problem? Simple था, simple concept है. कोई भी doubt है इसमें पूछ लो. If you have any doubt, you can ask. If you have any doubt in this concept, you can ask. Okay, simple है. IT is equal to I naught e raised to power minus t by tau. Now, one thing you need to understand here, if in this question, I'm going to ask you, how much energy is going to dissipate in resistor, then what will be the answer? सोच के बताओ. अगर मैं पूछा हूं कितनी energy resistor में dissipate हुई है, कैसे निकालोगे? How much energy is dissipated in the resistor? Anyone? How much energy is dissipated in resistor? देखो सिंपल है, कैसे निकालोगे? आपको दिख रहा है कि इंडक्टर ने एनर्जी स्टोर की हुई है. इंडक्टर हैज स्टोर्ड द एनर्जी, सो द टोटल एनर्जी स्टोर्ड बाय इंडक्टर इज इक्वल टू द टोटल एनर्जी डिसिपेटेड बाय रेसिस्टर. टिल स्टेडी स्टेट ऑल द एनर्जी दैट हैज बीन स्टोर्ड इन इंडक्टर हैज बीन डिसिपेटेड इन रेसिस्टर. सो वो एनर्जी होगी क्या? दैट एनर्जी which is dissipate in resistor is nothing but equal to half Li square. What is half Li square? This is the initial energy. This is the initial energy stored in inductor. This is the initial energy stored in inductor. Yeah. So this type of question also they can ask you. Yes, L ने कितना store किया था, correct, consume किया था. ठीक है. So this type of question also they can ask you about energies. Okay. कि एनर्जी कितना स्टोर हुई, और दे कैन आस्क यू कि इतने टाइम तक, फॉर एग्जांपल इफ आई आस्क यू हाउ मच एनर्जी विल बी स्टोर्ड टिल, हाउ मच एनर्जी विल डिसिपिएट टिल t इक्वल टू 2 मिलीसेकंड्स, तो इस टाइप से एक पर्टिकुलर इंस्टेंट पर भी दे कैन आस्क यू द एनर्जी। सो एनर्जी के क्वेश्चंस भी हम देखेंगे, तो ध्यान रखना कॉन्सेप्ट कैसे यूज होता है। नाउ इफ आई टॉक अबाउट द फोर्स्ड आरएल सर्किट, if I talked about the forced RL circuit. Now forced RL circuit means we are going to apply the voltage source here. We are going to apply the voltage source here. Let's suppose this is Vs. I have a switch. This is inductor and this is resistor. Now I'm going to assume that inductor is charged initially. So assume करते हैं, assume inductor is charged initially. Inductor is charged initially such that initial current I0 plus is equal to 0, is equal to I, sorry, initial current I0 plus is equal to I. Okay, again simple hai, again the concept is going to be simple. In this particular concept, the initial current is already given. It is given that inductor is charged initially. So if inductor is charged initially, I can directly use the formula. But before that, I have to find out what will be the current at t tends to infinity. Can anybody tell me what will be the current at t tends to infinity? Simple hai. You have to draw the circuit at t tends to infinity. So at t tends to infinity, what will happen? Inductor will be short circuit. याद करो, in yesterday's class I gave you the whole table. In yesterday's class I gave you the whole table. I told you if you are going to a steady state, inductor will be short circuit and capacitor will be open circuit. So same here, inductor will be short circuit. So at t tends to infinity, inductor will be short circuit like this. We have a resistor like this and we have a source voltage like this, plus minus Vs. Now this is the inductor current at t tends to infinity, right? So what will be the I infinity? I infinity will be Vs by R. It means this amount of current is going to pass through inductor at t tends to infinity. Initially the current is I. Now the current is Vs by R. Now I can apply the formula directly. What is IT? You can see the formula. You can see the formula here. This is the formula. So I infinity minus I0 plus e raised to power minus t by tau. Here, what is tau here? Tau is equal to L by R. What is tau here? Tau is equal to L by R. Do you get it? Tell me guys. Do you get this concept? Yes or no? Do you get this concept? Jaldi se batao. Any doubt in this concept? Any doubt in this concept? And I can see today बच्चे कम है, तो बच्चों सेशन को शेयर करो, जो बच्चे ऑनलाइन है सेशन को शेयर करो जिससे कि ज्यादा से ज्यादा बच्चे आ सके। एंड बच्चों जो लाइव जो रिकॉर्डेड सेशन देखते हैं ना, उनको एडवाइस है कि आप लोग लाइव सेशन देखा करो, ठीक है? रिकॉर्डेड देखोगे तो आप डाउट्स नहीं पूछ पाओगे मुझे उस पर्टिकुलर सेशन में, ठीक है? नाउ लेट्स गो फॉर द, वी कैन ऑल्सो ड्रॉ द कर्व ऑफ इट, वी कैन ऑल्सो ड्रॉ द ग्राफ है, ग्राफ हियर यू कैन सी with respect to time we have a current IT. Now initially the current stored is something I. Finally at t tends to infinity the current is Vs by R. As you can see here, the I infinity, the current is Vs by R. So how can you draw the curve? You can draw the curve like this. You can draw the curve like this, right? And out here simple concept है. Sometimes they can ask you to actually select which curve is actually giving you the current here. So they will give you the 4 option. You have to select the right answer. So because of that, you should understand किस तरीके से हम इसको निकालते हैं. Also we can find out the inductor voltage. Inductor voltage formula is equal to L di by dt. L di by dt. So we have L d by dt of Vs by R. Let me check. We have Vs by R minus Vs by R minus I e raised to power minus t by tau. Now if you differentiate this with respect to time, Vs by R equal to 0, it comes out to be 1 by tau Vs by R minus I e raised to power minus t by tau. Tau is L by R, so it comes out to be Vs minus IR multiply by e raised to power minus t by tau. So this comes out to be the inductor voltage. This comes out to be the inductor voltage. Okay. So remember, questions are simple. You just have to focus the table I gave you in a last class, how to solve the questions of transient, and then go for it. Now we are going to solve few questions here. This is the first question on your screen. This is the first question on your screen. So we have already seen almost all the concepts that we are going to use in our transient. There are few concepts left that we are going to learn through questions. Okay. So this is the first question here. If the switch in figure opens at t equal to 0, find for t greater. Achha. Let's write down. Find capacitor voltage for t greater than 0. The question is find capacitor voltage for t greater than or equal to 0. Try karo, aram se try karo. If you want to identify this circuit, as you can see, this is the RC circuit. So tell me, is this a source free or a forced circuit? Tell me guys, क्या ये source free circuit है या forced है? सोचिए बताओ. Is it a source free circuit or a forced circuit? No one? देखो, after a switch has been opened, the source has been removed from here. That's why it is the source free circuit. If after the switching you have a source in a circuit, then it will be a forced network. Okay. So in this way you can identify which type of circuit you have, right? So let's see. We need to find out the capacitor voltage here. Okay. We need to find out capacitor voltage here. Before that, you can see, you can simply combine these to the system. 12 parallel to 4. It comes out to be 12 multiplied by 4 divided by 12 plus 4. It will comes out to be 3 ohm. So the resultant of this will be R equal to 3 ohm. Now to solve any question of transient, first you need to find out the initial condition. So here we have a capacitor. So first we need to find out the capacitor voltage here, initial voltage. So for initial voltage, I will draw the circuit at t equal to 0 minus. Now what will happen at t equal to 0 minus? This capacitor will be act like a open circuit. This is 3 ohm. The switch has been closed. It is 6 ohm. It is plus minus 24 volt. And we need to find out this voltage, VC 0 minus. Now tell me, what will be the VC 0 minus? See very carefully. The voltage across 3 ohm. So can we apply the KVL? Current. We can apply the voltage division rule. 3 divided by 3 plus 6. So it comes out to be 8 volts. Correct. Ananta has given the answer. Good afternoon, Sheikh. Beta, be on time. So VC 0 minus comes out to be 8 volt. Now VC 0 plus is equal to VC 0 minus. Why? This is a property of a capacitor that voltage across it does not change instantaneously. I can see today because of the match, students haven't come into this class because ये topic काफी important है एग्जाम के लिए. मैं बता रहा हूँ, जितना जल्दी रिवाइज करके इसके ऊपर क्वेश्चन लगाओगे ना, उतना आपके लिए फायदा है. But I guess match is also important. So VC 0 plus equal to VC 0 minus equal to 8 volt. Now, after a switch has been opened, the circuit becomes the source-free RC circuit. For the source-free RC circuit, remember the capacitor is going to discharge completely at t tends to infinity. So can I say what is VC infinity? It will be 0 because capacitor ही आपका energy दे रहा है after switching, so it will going to be completely discharged. So and what is the time constant? Time constant is RC. R is 3 ohm. Capacitance is 1 by 6. It comes out to be 1 by 2. Now put every value in this formula. VCT is equal to VC infinity minus VC 0 plus e raised to power minus t by tau. है ना? So VC infinity, it is 0. It is also 0. It is VC 0 plus is 8. E raised to power minus 2t. So simply answer comes out to be 8 e raised to power minus 2t, and Anant has given the right answer. Very well done, bache. Very well done. It comes out to be 8 e raised to power minus 2t. And let me tell you, this was the question from EC gate examination, previous year question. Any doubt here? है ना. तो ट्रांजिएंट क्वेश्चन सिंपल आते हैं, जस्ट यू नीड टू अंडरस्टैंड द बेसिक्स. Just you need to understand the basics. Now, next question. Important here. Why this is an important question? Because whenever you see a dependent source connected inside a transient, that question become important. So here we need to find out I and Vx in the circuit shown in the figure when I naught is equal to 5 ampere. Now they have already given the initial current here is a 5 ampere. So we need not to find out the initial condition here because it is already given. Now if you see this circuit, this is a first order circuit. First order circuit means only we have an inductor here as an energy storage element. So we can apply the shortcut formula. What is the shortcut formula? That IT is equal to I infinity minus I0 plus e raised to power minus t by tau. This is the formula. So I0 plus is already given in a question, which is 5 ampere. Let's first find out the I infinity. I infinity means you have to draw the circuit at t tends to infinity. Now always remember, at t tends to infinity, inductor will be short circuit. Inductor will be short circuit. So here I can say inductor will be short circuit. This is plus minus 2Vx. This is plus minus 2Vx. You know, and here we have 4 ohm. Here we have 4 ohm like this. This is 4 ohm. This is 1 ohm. This is 4 ohm. This is plus minus Vx. We need to find out here I infinity. Okay. So think about it. How will you find out? How will you find out I infinity? एक बार सोचो, comment section में आंसर दो मुझे. I infinity का यहाँ पे आंसर क्या होगा? Think about it. Give the answer in a comment section. What we can do here? What we can do here? What we can do here? सोचिए बताओ. Let's see, are you able to give the answer or not? देखो simple है कैसे. Let's suppose I'm going to take this as a reference node. This is going to be voltage V. So I infinity goes here. Let's suppose some current is also goes here, I1 and I2. So can we apply the KCL here? Can we apply the KCL here? Right? So I can write down according to KCL, I infinity plus I1 plus I2 is equal to 0. Why? Because all the currents are leaving the node. All the currents are leaving the node. Now what is I infinity? I infinity is V by 4. I infinity is V by 4. ठीक है? Simple सी बात है. What is I infinity? V by 4. What is I1? V minus 2Vx divide by 1. V minus 2Vx divide by 1. ठीक है? What is I2? I2 is V by 4. I2 is V by 4 equal to 0. Let me check. Correct. Now see very carefully. You can also see beta what is Vx. If you see very carefully, I infinity is coming in this direction. So because of I infinity, the polarity become plus minus. So Vx has a different polarity. So can I write down Vx is equal to minus 4 times of I infinity? Yes or no? जल्दी से बताओ. Can we write down Vx is equal to minus 4 times of I infinity? Apart from that, I can also write down what is I infinity. It is V by 4. So you can say it is equal to minus V. It is equal to minus V. So here I can say V by 4 plus V. Vx is minus V के equal है. 2V plus V by 4 is equal to 0. What you will get here? Tell me. What you will get here? From here, you can get V tends to 0. And if V tends to 0, I infinity is also going to be 0. If V tends to 0, it means I infinity is going to be 0. Now understand the concept here very carefully. Why I am saying key dependent source method is important. Understand this concept very carefully. If you observe the circuit, there is no independent source. If there is no independent source, how does the network is going to energize? The network is going to energize because of the inductor present here. This inductor is initially charged with some current 5 ampere. So that's why this inductor is going to energize the circuit. This inductor will behave like a source. Since this inductor will behave like a source, so this will discharge the energy that has been stored inside it. So what will happen? At t tends to infinity, all the energy will be discharged from inductor. At t tends to infinity, all the energy will be discharged from inductor, and if all the energy will be discharged from inductor, obviously बात है कि जो करंट होगा इंडक्टर का I इंफिनिटी पे वो जीरो ही होने वाला है. So there is no need to do all the analysis here from t tends to infinity and all of this. There is no need to do the analysis here because बच्चों the inductor is acting like a source, and after t tends to infinity, the inductor will be completely discharged, and the particular energy stored will be zero, and that's why I infinity will be zero here. Understand this concept? तो कभी भी डिपेंडेंट सोर्स आए और उसमें आपके पास कैपेसिटर या इंडक्टर लगा हो, तो याद रखना अगर कोई भी एक्टिव सोर्स, कोई भी इंडिपेंडेंट सोर्स आपके पास नहीं है, तो उस केस में इन्फिनाइट पर इंडक्टर कैपेसिटर कंप्लीटली डिस्चार्ज हो जाते हैं और उनकी फाइनल कंडीशन जीरो हो जाती है. ठीक है, समझे इस बात को? तो उसमें हमें इतना सब करने की जरूरत नहीं थी अगर ये कॉन्सेप्ट हमें पता था, और ये करके भी आप देखो आंसर आपको जीरो ही आ गया. राइट, सो वी हैव फाइंड आउट द आई इंफिनिटी, आई जीरो प्लस इज गिवन. Now the main point is here is to find out the time constant tau. Is to find out the time constant tau. That is important. Now what is tau? Tau is actually equal to L by R. Tau is actually equal to L by R. Now understand this point carefully. Inductance is given. That's okay. I need to find out that total resistance. I need to find out that total resistance. Now the total resistance is always find out from the inductor terminal by taking that particular terminal as load terminal, and Anant is saying absolutely correct. We have to find out this as according to the RTH. जैसे RTH हम निकालते हैं ना, dependent source दिया होता है, we actually use the test source method. The same thing we are going to do here. So we have to use the test source method to find out the RT, or you can say RTH. So let me do one thing. I will do here. Let me erase all of this, because I told you there is no need to do this, because if you know the concept, the inductor will discharge, so you can easily say that I infinity, the current will be zero. At t tends to infinity, the current will be zero. Okay, now we are going to use the test source method. We are going to use test source method. Okay, so कैसे करें? Inductor will be act like a load terminal, so I am going to apply the plus 1 volt there. This is 4 ohm plus minus Vx. That why we are using a test source method? Because dependent source is given. 2 times of Vx. Here we have 4 ohm. This is 1 ohm, and from here the current pass through is I. So what is going to be RTH, or simply RT, because we are using RT, it is 1 upon I. ठीक है, तो कैसे फाइंड करेंगे? We have to find out the value of current I. Taking a reciprocal, I can find out the total resistance from inductor terminal. ठीक है, कैसे फाइंड कर सकते हो? First of all, you can see here what is Vx. Vx is equal to 4 times of I. I can see here Vx is equal to 4 times of I. Okay. Now after going further, I can see और क्या लगा सकते हैं यहाँ पे हम? KVL लगा दे, KCL लगा दे. KCL की एक इक्वेशन आएगी, KVL की 2 आएगी, तो यहाँ पर हम KCL लगा देते हैं. This is V. So if you apply the KCL, it will be 1 minus V divided by 4. 1 minus V divided by 4 is equal to V minus 2Vx divided by 1 plus V by 4. V minus 2Vx divided by 1 V by 4, है ना? We can apply the KVL like this. कोई डाउट है इसके अंदर किसी को? Anybody has any doubt here while applying the KCL here? Once we have applying the KCL here, you can also see very carefully, बच्चों, if you apply KVL, it will be minus 1 plus Vx plus V equal to 0. So from here I can say Vx comes out to be, from here I can say Vx comes, V ले लेते हैं. From here I can say V comes out to be 1 minus Vx. V comes out to be 1 minus Vx, like this. Now this is the equation. This is equation we have. This is the second equation we have. We can use both the equations, find out the answer. कैसे? ये क्या है? 1 minus V. तो V की जगह हम पुट कर देंगे Vx. There is no need to do this. We can erase this one. Already we have justified the relation that I infinity will be 0, है ना? So here we will have 1 minus V by 4. So it will be Vx by 4. It will be Vx by 4 equal to 1 minus Vx. So 1 minus 3 Vx. 1 minus 3 Vx by 1 plus 1 minus Vx by 4. So it comes out to be Vx. It comes out to be Vx equal to 4 minus 12 times of Vx plus 1 minus Vx. You can check the calculation also. It will be 14 Vx equal to 5. So from here, Vx comes out to be 5 by 14. If Vx is 5 by 14, what is going to be I? I is actually equal to Vx by 4. So I comes out to be 5 by 56. I comes out to be the 5 by 56. So finally, what is RTH? Or I can say RT. It is equal to 1 by I. So it's going to be 56 by 5. 56 by 5. Now finally, time constant is equal to L by RT. L कितना यहाँ पे 2 Henry. So 2 divided by 56 multiplied by 5. It comes out to be 5 by 28. So we got the time constant as 5 by 28. This time constant actually comes for 1 marks. Means ये पूरा क्वेश्चन आपका 2 मार्क्स का है, जिसमें से 1 मार्क आपके टाइम कांस्टेंट निकालने के लिए होता है. So finally I can say what is IT? What is IT? I infinity is 0. I infinity is 0. Initial current given, which is the 5 ampere, which is given here, 5 e raised to power minus t by tau, which is 28 by 5. Right? 28 by 5 t. So it comes out to be 5 e raised to power minus 28 by 5 t. ठीक है, कॉन्सेप्ट तो ध्यान समझो. मे बी अगर कहीं कैलकुलेशन रॉन्ग होगी तो मुझे बता देना, ऐसा कोई दिक्कत नहीं है. बट द कॉन्सेप्ट हियर इज, फर्स्ट यू शुड अंडरस्टैंड whenever you have a dependent source present without any independent source, at infinite either there will be a current or voltage that will be zero. First you need to understand this across the energy storage element. ठीक है. Second you need to understand when you are going to find out a time constant in case of dependent source, then you have to use the test source method to find out the total resistance. Test source method we have already done in case of RTH. So using a test source method, we can find out like this. And finally, from a time constant, you can find out what is the IT. ठीक है, 2 marks question है, काफी अच्छा question है. This type of question actually tells you how much you are going to score, because only and only 20 to 25% students are able to solve this question in examination, and rest of 75% बच्चे will drop this question. Okay, so that's why those 25% students will decide what is going to be the rank of remaining 75% student. Okay, so understand this. You have to come under those students. Network, signals, analog, they are very, very scoring subject if you have a strong base. Okay. Okay, before going further, let me tell you one thing. That we have already, you can download our BYJU'S exam prep app. In this particular app, you are going to get daily classes of different subject by different faculty. In this particular app, we also have a very good option in which we are actually giving you the quiz. From the quiz, you can score and you can check where you stand among all the aspirants which are going to give exam. And also, bachcho, I have already started analog electronics on the app at 4:30 p.m. in which I am discussing the previous year questions from electrical and EC. In yesterday's class, I have discussed the 2016 and 2017 question. In today's class on app, I will discuss 2018 and 19 question from analog electronics. So don't forget to attend this particular class. It will help you to understand the question, understand the concept through questions. Okay. Now let's solve this question. Find Vt for t greater than 0 in the circuit of figure. Assume that switch has been opened for a long time and is closed at t equal to 0. Okay. And after that, we have to find a voltage at t equal to 0.5 seconds. So simple hai. Once you find out the equation of Vt, after that you can find out the voltage also by putting t equal to 0.5. Hai na? So try to solve this question. Again, this is a 2-mark question. And bachcho, we have 2 classes left, tomorrow and a day after tomorrow. In those 2 classes, we are going to do the unique question and also the second order questions. Okay. So let's see. Today we are going to focus on first order circuit only. Because for exam perspective, 75% question that comes from an transient analysis are from the first order circuit. तो solve करते जल्दी से. So the first step to solve this question is to find out the initial condition. Now initially the switch has, they have given that the circuit of figure, assume the switch has been open for a long time. So initially the switch has been open. So this switch has been open initially. It means you only have this network. You only have a this network. Since we only have a this network, the capacitor is in series with the voltage source. So what is the initial voltage that has been stored in capacitor? That is equal to 10 volt. So this we can write down directly that initially voltage across a capacitor is nothing but a 10 volt. Now at VC0 plus also we have a 10 volt, no worries. Okay, VC0 plus we have a 10 volt also, because of the capacitor property that voltage across it does not change instantaneously. Now let's find out voltage at t tends to infinity. So at t tends to infinity, what will happen? Capacitor will be open. Capacitor will be open. The switch has been closed. The switch has been closed. The capacitor is open. We need to find out plus minus V infinity. Here we have minus plus. Here we have minus plus. Here we have plus minus. So this is 10 volt. This is 5 volt. This is 6 ohm. This is 2 ohm. So try to find out V infinity. Try to find out V infinity. What will be the V infinity here? Simple concept. How can you find out V infinity? कैसे find करोगे? बताओ मुझे. सोच के बताओ. Can we find out the current flows here? Simple है. Can we find out the current flow here, which is minus 10 plus 8 times of I, minus 10 plus 8 times of I, 8 times of I minus 5 equal to 0. From here, the I comes out to be 15 by 8. From here, I comes out to be 15 by 8 ampere. From here, I comes out to be 15 by 8 ampere. Simple. So, what will your V infinity? V infinity will be minus 10 plus 2 times of I plus V infinity equal to 0. Or I can say V infinity is equal to 10 minus 2 times of 15 by 8. So it comes out to be 40, 40 to 15 and 25. It comes out to be 25 by 4 volt. It comes out to be 25 by 4 volt. Any doubt? ये कैसा है? Simple ना? Simple KCL KVL. Nothing extraordinary we are doing. We are just applying the KVL KCL. Let me check the calculation also. 10 minus 2i. 2i तो 4 आया. 40 minus 15, 25 by 4. Correct. We have got it. Now we need to find out the time constant. Now for a time constant, बच्चों, let me add page here. Let me add one page. So we need to find out time constant. For this, I need to find out RTH. Now for the total correct for total assistance, the voltage source will be short circuit. The voltage source will be short circuit, and you need to find out total assistance from the capacitor terminal from here. Total assistance from a capacitor terminal. It is 2 ohm. It is 6 ohm. So if you see from this side, can you say what is RT? RT is 2 parallel to 6. RT is 2 parallel to 6. 2 multiplied by 6 divided by 8. So it comes out to be 12 by 8. It comes out to be 3 by 2. So RT comes out to be 3 by 2. Yes or no? RT comes out to be 3 by 2. What is the time constant finally? Time constant is L by RT. Now what is L here? Sorry, we have capacitor. Sorry, we have a capacitor. So time constant will be R multiplied by CT. We have a capacitor here. Time constant will be RT multiplied by C. 3 by 2. What is capacitance here? 1 by 3. So it comes out to be 1 by 2 seconds. So finally, put all the values in this formula. That Vt is equal to V infinity minus V0 plus e raised to power minus t by tau. So V infinity is 25 by 4 minus 25 by 4. V0 plus is how much? It is 10. It is 10. E raised to power minus 2t. So from here I can say minus 40, minus 40 15. So कितना जाएगा? 25 by 4 plus 15 by 4 e raised to power minus 2t. This is the voltage across the capacitor. This is voltage across capacitor. You can change the answer in decimal form also. You can change the answer in decimal form also. Okay? Any doubt here? Any doubt till here? जल्दी से बताओ. Okay, so these type of first order circuit are very good. You can see this type of questions in your exam. Tomorrow we will do the second order question and also some unique question, and the day after tomorrow we are going to do only the unique questions. So you will get every type of question that may ask in your examination based on the questions that they have been asked in past or previous year exams. Okay, let's do one more. Okay, let's do this question. Also, it's a 2-mark question. It's 2-mark question, has been asked in GATE examination in instrumentation exam, if I'm not wrong. The switch in the figure below was closed for a long time. It is opened at t equal to 0. The current in the inductor for 2 Henry for t greater than 0. So we need to find out the current in the inductor. So tell me, how we can solve this question? See, we have given options also. From options also, you can solve the question easily. If you observe the options, there have been a different time constant given. So you can find out the time constant first and eliminate the options here. Okay. So to find out a time constant here, the time constant will be L by R or L by RT. So we need to find out the total resistance here first. Okay. Now the switch has been opened. So the time constant will find out only for the circuit after switching. So for this circuit, I need to find out a time constant. Okay. So what will be RT, बच्चों? RT क्या होगा? Total resistance will be observed from the energy storage terminal. Total resistance will be observed from the energy storage element. So if you observe from here, you can see 32 ohm are in parallel, 8 and 8 are in series, and the resultant is in parallel. है ना? So I can write down what is RT. RT is 32 parallel to 32 parallel to series resultant of 8 plus 8. 32 parallel 32 16 हो गया. Parallel to 16 कितना आ गया? 8 ohm. So RT comes out to be 8 ohm. Now what is the time constant? Time constant is L by RT. L कितना है? 2. So 2 by 8, it comes out to be 1 by 4. 2 by 8, it comes out to be 1 by 4. So it means which options is going to eliminate? Option D and option C. Option D and option C is going to be eliminated. Why? Because if you remember, the exponential equation given is e minus t by tau. Tau is 1 by 4. So the 4 will come with the multiplication of t. So option D and option C will be cancelled out here. Option D and option C will cancel out here. Any doubt? Any doubt here? Now simple. Now if you see, again next difference is their initial condition. Now if you see here, the initial current here given is 5. The initial current here is given is 2.5. So if I'm able to find out what is the initial current stored in the inductor, then I can get the answer directly. है ना? तो वो कैसे find करेंगे? To find out the initial condition, let me see. हाँ. To find out the initial current, always understand you have to draw the circuit at t equal to 0 minus. So at t equal to 0 minus, the switch has been closed. This is 8 ohm. This is 8 ohm. 32 and 32, I can take it as a parallel. It will be 16 ohm. And inductor will be short circuit like this. Plus minus 50 volt. So I need to find out what is the current at I equal to 0 minus. What will be the current? कैसे find करोगे? Simple KVL कैसे लगाना है? मेरा 0.5 कैसे आ गया? वोल्ट हो ना वो तो हमें एम्पियर में निकालना है. 0.5 कैसे आ गया? Now I0 minus कैसे find करेंगे? Simple. 16 ohm has been removed. Here you can see 8 ohm and 8 ohm are in parallel. So what is the equivalent resistance from here? 8 ohm and 8 ohm are in parallel and in series with 6 ohm. So I can say the equivalent resistance here is, let me check one point. 8 ohm and 8 ohm are in parallel. है ना? So 8 parallel to 8 plus 6. So it comes out to be 10 ohm. So what is the total current flowing here? Total current flows here is 50 divided by 10. It comes out to be 5 ampere. Now this total current is going to divide further. This total current is going to divide further here and here also. Okay. So what is the I0 minus? IT divided by 2. Kyun? Because 8 ohm and 8 ohm both are equal resistor. So 5 divided by 2 equal to 2.5 ampere. So the initial current you got is 2.5 ampere. If you got 2.5 ampere, option A is the right answer. Option A is the right answer. So from options also, you can find out answer by using the initial condition, by using a time constant. Okay, understood this problem? Okay, simple tha question. Now let me give you few information. Tomorrow we are going to do question over the second order circuit, and some unique questions we will also do that has been come in a previous year examination. Apart from that, beta, I can see today the students are very less, and it's really disappointing कि स्टूडेंट पहले क्लास में आते हैं फिर उसके बाद क्लास में नहीं आते हैं. ठीक है, आपके लिए इतना अच्छा इनिशिएटिव लिया जा रहा है, तो अगर आप क्लासेस में आओगे तो हमें भी मोटिवेशन मिलेगा, हम और ज्यादा इनिशिएटिव लेकर आएंगे. अब बताओ, आई एम थिंकिंग अबाउट टू स्टार्ट समथिंग एल्स फ्रॉम नेक्स्ट वीक. सो अब मैं कैसे स्टार्ट करूँ, इवन बच्चे अगर कंटिन्यू नहीं रहेंगे तो, है ना. सो कंटिन्यू रहो. और एक और चीज है, नेक्स्ट वीक के लिए अगर आपको कुछ स्टार्ट करवाना है YT पर ऑन द सेम टाइमिंग, आप कमेंट सेक्शन में मुझे बता सकते हो कौन सा टॉपिक आपको चाहिए. ठीक है, आई विल अरेंज द क्लास फॉर दैट फ्रॉम द नेक्स्ट वीक. तो आप कमेंट सेक्शन में बता सकते हो कोई कौन सा सब्जेक्ट या कौन सा टॉपिक आपको चाहिए. एज यू नो, अदर फैकल्टीज भी सब्जेक्ट ले रहे हैं. फॉर एग्जाम्पल संजय सर की भी क्लास चल रही है, साकेत सर की भी क्लास चल रही है ना, है ना. राजू कह रहे हेलो सर, आई एम न्यू स्टूडेंट, अगर आप टाइम चेंज कर सकते हैं प्लीज. राजू बेटा, इस मंथ यही टाइम रहेगा बिकॉज वो पहले से फिक्स था. बिकॉज यू कैन सी कि संजय सर की भी क्लास चल रही है ना, और साकेत सर की भी क्लास चल रही है, फिर राकेश सर की भी क्लास होती है, तो थोड़ा टाइम का स्लॉट थोड़ा बिजी था. नेक्स्ट मंथ से मैं ठीक कर लूंगा. अनंता बेटा, सिग्नल सिस्टम ना नेक्स्ट वीक ऐप पर स्टार्ट हो रहा है, जिसमें प्रीवियस ईयर क्वेश्चन डिस्कस करने वाला हूँ सिग्नल सिस्टम में, और एनालॉग के मैं इस वीक डिस्कस कर रहा हूँ. आपके नेटवर्क में हमने ट्रांजिएंट और 2-पोर्ट नेटवर्क ले लिया है ना. तो अब एक टॉपिक और बता देना, वी विल टेक क्या एनालॉग से नेटवर्क्स कहीं से भी, वी विल अरेंज द क्लास फॉर दिस फॉर नेक्स्ट वीक ऑन यूट्यूब. तो अभी इस पर्टिकुलर सीरीज में हमारे 2 क्लास बची है. टुमारो एंड डे आफ्टर टुमारो. तब तक कमेंट सेक्शन में जो बच्चे रिकॉर्डेड सेशन देखेंगे उनको एडवाइस है कि एक बार मुझे बता देना, आई विल अरेंज द क्लास अकॉर्डिंग टू दैट. ओके, सो बाय गाइस, टेक केयर. ऑल्सो बिफोर एंडिंग अ सेशन, लेट मी टेल यू वन पॉइंट, that you can join our crash course if you are going to prepare it for very well for your upcoming GATE examinations. In this, we are providing you live quizzes, practice quizzes, recorded lecture, mock test and study material, and you can revise the concept in a very less amount of time and with a lot of questions and lot of practice. Also, we will provide you the guidance from our site ki how you can ace your examination. Okay, so don't forget to join this particular crash course. So bye guys, take care. And see you tomorrow on the same time of 3 p.m. where we are going to discuss the second order question.